Welcome to the course Object Oriented Analysis and Design OOAD with UML and Java. This course presents an introduction to object oriented design with the unified modeling language and the Java programming language. The course assumes no prior knowledge of the object orientation on the part of the listeners. However, some experience with Java programming language or any familiarity with the object-oriented part is expected. So the emergence of object-oriented OO method offer the opportunity to introduce the object-oriented modeling and design into development process before they start the actual implementation. So rather than going through that, let's let's say that there are two steps to make any applications. First is design, like what you are going to make. Second one is how to make, that is the implementation part. So it's very pre-qualified that we have to complete the first step, that is the design, and then we will implement with Java or any language of your choice. In this whole course, we have used UML diagram to capture the details of their design without need to embrace the Java language. It is beyond the any language support because it has sufficient expressive power to record the classes, their basic attribute, their relationship with other classes, and the behavior of their operations. The important benefit from this approach is that there is a significant shift of the emphasis away from the detailed programming difficulties or any other constraint that we are going to discuss in the next subsequent lectures. So, as a mapping from the model to the implementation are developed, we recognize the emerging and repeated patterns. So, as a consequence, more of the programming collapse into the coding course. So, it's very important phase on how to design your applications, and it should consider all the requirement and the constraints in a very effective way, so that as a developer we should not face any issue in the later stages. So I told you in earlier stage also, like there are two phases of any application development. One is the analysis phase and one is the design phase. So analysis phase is nothing but it is to create the functions model. It's a kind of functional model of any system regardless of the system constraints and technical constraints. So this is done by numerous use cases and abstract definition of the most important object. Then comes to the design phase. So subsequent design phase redefines the analysis model that we have done in the previous steps and make some modification or adopt the technology based on the implementation or the client choice, you can say. So this phase has all the detailed requirement so that programmers can implement the design easily with their choice of language. So here I am talking about the constraint. So constraint is like, it may be a hardware constraint, it may be a budget constraint or time constraints or any software issues. Right. So we will discuss all this detail. I've just given one idea, one holistic overview, like what we are going to make and learn. So in the next section, we are going to discuss what is OOAD, Object Oriented Analysis and Design. Then we will discuss why it is required in a detail. Until then, bye. Welcome back. In this section, we are going to understand what is OOAD. OOAD stands for Object Oriented Analysis and Design. So there are two parts in OOAD. One is stand for OA and another is Object Oriented Design, that is OOD. So Object Oriented Analysis stands for the functional detail without any constraints. So it's very important to know what we are going to make, what our software is going to do, the system that we are aiming to design. So it's a kind of functional capture of the required software that we are going to execute. So this functional details without any constraint is comes in the section OOA. object oriented analysis, and how this function will be achieved with some language or tools, that comes in the part of OOD, that is object oriented design. So OOA emphasizes on what we are going to make, and OOD stands for how we are going to achieve this. So we know that any software system is actually a model of a problem that exists in the real world or your imaginary world. So therefore, more closely a software model correspond to the actual problem, then it will become more effective, right? So OAD methods recognize this fact and use the key abstraction taken from the problem's domain as a fundamental building blocks of the software system. So to design any software system, we have three approaches. One is the use case diagram, another one is the architecture centric approach, and third one is the iterative and incremental approach. So in use case diagram, if I talk about this, so in use case diagram, it is a typical interaction between the user and the system under development. It is used to the capture the some functionality to be provided by the software system. For example, if I consider a banking application use case, so you know that there may be a many document that a requirement of the system is to support transaction of the bank document. So if I talk about the bank accounts, so the functionality can be like you have to deposit some money, or you have to you have to withdraw money, or you have to print your passbooks, right? So this is all functionality, and this functionality can be achieved through use case diagrams. Developing a use case is a significant activity in the OOAD process. There can be used to communicate with the client as a statement of the intent for the developers and specifications for the testing that should be applied to a system when it comes under the development. So you normally see that like whenever design or develop any application, so when you want to test the application, you test the functionality and you write some some use cases for that. So this is what the use case diagram used to do when you consider it this as an approach. So this is one of the very famous and acceptable approach. Now coming to the architecture centric. So architecture centric is a process where we make systems architecture the primary focus during the development. It means a model presented as a various UML diagrams gives different perspective of the system. Some diagram emphasize on the static structure of the system architecture, while others can capture some dynamic behavior. Like if you talk about any student portal where a student used to study, so there may be two kind of design over here. One design is to keep the student data on some cloud services, so this will be a static applications, a static approach or a static architecture. And another can be while capturing the all the metadata of what student is reading online. It can be a time frame, it can be a page number, it can be some bookmarks, it can be anything, right? So this is how the architecture centric approach used to work. Okay, so with this approach there is only one model of the system no matter what stage of the development it is at, right? So if I consider one example for the school portal, so there are three users for that, suppose parents, student and teacher. So in the same system, when three different users logged in, they find the different view, different kind of design. So this is all three different view of the same system which is developed using the approach of architecture centric, right? Now coming to the iterative and incremental design approach. So in this approach, we aims to release the series of version of the software, and each version of the software has all the functionality that it previous version is having with some additional or new functionality. So we need to ensure that each iteration has a clearly defined aim to avoid any undisciplined development. Some interaction may not be involved new things or new design, but are concerned with the redefining or refactoring the model to enhance its quality and performance or usefulness. So this is how all these three approaches are used to design any system. Now, why all this design and why this is OOAD is important, we will discuss in the next section. Until then, bye. Welcome back. In this section, we are going to understand why this object-oriented analysis and design required. What is the importance of this? So, just to recap what we have understood so far is that object-oriented modeling is a common approach to modeling application system or any business domain by using the object-oriented approach. And this object oriented modeling is a main technique heavily used in both object oriented design and object oriented analysis activities in modern software engineering. In a nutshell, this object oriented modeling typically divides into two aspects of the work that we have discussed earlier also. This modeling of the dynamic behavior like business processes or use cases, and the modeling of the static structure like classes and its component. So, in short, OA and OOD are two distinct abstract level. One is the analysis level and another is the design level. And to demonstrate this both level, we use UML, and which is very popular object-oriented modeling technique. Now coming to the benefits of it. So first benefit is that effective and efficient communication. Users typically have difficulties in understanding the comprehensive document and programming language codes as well. When you join any new project, so it's very difficult to understand the application domain with the code. It will be always better when you got some visual representation of the components. So visual model diagrams can be more understandable and it allow users and stakeholders to give developers a feedback on the appropriate requirement and structure of the system. So the key goal of the object-oriented approach is to determine the systematic gap between the system and the real world, and to have the system to be constructed and discussed among the different level of stakeholder in the same language. So it will always be good to have business language and object-oriented modeling as an essential tool to facilitate this. So this is one of the business language we can say UML. Now coming to the second point, that is useful and stable abstraction. So O is always stand for what we are going to make, and OD always stands for why and how we are going to make. So it's always modeling helps coding, right? If you got the model, you can code it because you know the behavior and its statics model. So the goal of the most modern software methodology is to first address what questions and then address how these questions will be solved. So first determine the functionality of the system to provide without consideration of the implementation constraints, right? So in the analysis part, don't consider the constraints, just think of the all the functionality or use cases that you're going to make. Then then after refining them into detailed design and codes by the constraints such as technology and budget and hardware or software, anything. So object oriented modeling enables this by producing abstract and accessible description of the both system requirements and design models that define their essential structure and behavior like processes object, which are very important and valuable development assets with a higher abstraction. So these are the two main benefits which helps ultimately in designing the system. In the next section we are going to discuss with some real approach and real example use cases considering some no real world problems, and we'll go by scratch one by one step by steps like how to design any given model. We will revisit it again and again to understand it more and refine it more. Until then, bye. Welcome back. Before diving into the design and analysis phase, first we have to understand some key term and terminology that is used in software development cycles. There are some steps to build any system, whether it's a software system or it's any materiality object. Like if I take one example, suppose you want to make a house. So before the house, you have to draw some layouts. Once the layouts is complete, then we have to design the interior parts. After that, you make your house and is ready to serve your purpose. In the same way, we have to do in the software development process. So there are four steps, and these steps are very much necessary to design any system. First one is requirement analysis. Second is design. Third is implementation, and fourth is delivery. So we will go one by one about this all these requirements, requirement analysis, design, implementation, and delivery. So software lifecycle usually begins with the requirement capture, in which we seek to determine the purpose of the software, like what we are going to make. Determining the requirement is usually performed in the conjunction of the customer. The outcome of this activity might be a short report, or it may be some number of pages, depending on the scale and complexity of the system. So frequently the requirement documents are subjected to interpretation. They can be incomplete or ambiguous because there are multiple ways to gathering this requirement. There might be if there are two-person or two clients which are explaining you the requirement, there may be differences. So it may be ambiguous or incomplete. So that further work is necessary to clarify these anomalies. So now with this standing, these failings requirements introduce the vocabulary of the problem domain and allow us to set its boundary. So when a requirement has been specified, the number of activities are undertaken. Some are repeated as we progress through the analysis, design, and rest of the phases like implementation. So if I say about these steps, so what we say in the very first step, we have to develop a set of use cases that describe the capabilities and we expect from the system. In many cases, we will initially fail to gather all of the use cases, but it's vital no, to try to capture the most important features. So there may be cases when requirement analysis is going on, there may be some cases a use cases is missed. There may be in the later stage you came across this requirement. So again you have to incorporate these requirements in the first step. So they provide a point of communication between the customer and the developer. So there can also help in correcting the ambiguous and customer and the developer. So correcting this ambiguous and omission in the requirement documentation. So this is how your documents requirement analysis become perfect, or moving towards the perfection, like what we exactly expected. Use cases can also operate as a basis of test cases since they define the functionality sought from the software. So once the requirements are completed, now you start analyzing the requirements. What is feasible, what is not feasible. So begin the analysis phase by populating what objects are present in the problem domain, how they can interact to achieve some parts of the system objective, and how they form relationships so that communication may happen. So this work consists of establishing a number of sequence, object, collaboration, and activity diagram that demonstrate how each use case is realized. The activity diagrams reveals some of the process within the system. The object and the collaboration diagram highlight the principal object drawn from the problem domain and their architecture. So collaboration and sequence diagram especially, this help to identify the document the behavior expectation of the object in the given problem domain. So requirement analysis, then this become a complete step. So first we have to analyze our system. You have to define multiple use cases. You have to make a set of use cases that describe the capability of the system. Once your capability is defined, then only you can analyze the requirement, right? So once this step is complete, now we're moving to the design part. In design part, developers and technical architects start the high-level design of the software and system to be able to deliver the each requirement that you have discussed in the first step. So the technical details of the design is discussed with the stakeholders and various parameters such as risk, technology to be used, capability of the system, other constraint like project related constraint, technical related constraint, time and budget, or all these are get reviewed. Then the best design approach is selected for the product or software cycle. So this is how in design we process starts. The selected architecture design defines all the component that needs to be developed and communication with the third party service. We have to draw a lot of user flow diagrams, database communication, as well as the front end representation and behavior of each component. So design is usually kept in the some document that is specially called design specification document, in short DST. In third step, we will try to implement our design. So in implementation, nothing but it's the coding part. So I mean, depend on the situation, user can choose any language of their choice. If they want to, choose any open stack technology or stack something, so they can choose or they can go for Java. If they want some paid version, they can go for .NET. It's all depend on the choice and available resources. So, I mean, once the requirement and design activity is completed, the next phase of software development process is implementation. So, in this phase, developer starts coding according to the requirement and design discussed in the previous phases. So, database admin create a necessary data in the database. Front-end developers create the necessary interfaces or some GUI to interact with the backend, all based on the guidelines and procedure defined by the company or your organization. So now developer can also write unit tests for each component to test new code that they have written and review each other code in the hierarchy within the team, and they create builds and deploy software to an environment where and another team or testing team can test the functionality and approve the approve the development. So this whole cycle of development is repeated until the requirements are met. So this is what we are doing in the step third and fourth. Here we are doing coding and we are testing the functionality that we have coded, whether it's by unit test or in some environment. If there is a drawback or some flaw, again it given back to the coding part. So again developer writes some code and complete that and then push the code to the tester again. So this is the cycle it used to keep on moving unless and until we reach the milestone or you complete the requirement of customers. So this is how software development process used to progress. The next concept we are going to learn this the multiple diagrams that is available in the system design processes. First we take a look at a class diagram. The class diagram is nothing but it's the representation of the class with the help of a rectangular box having three partitions. The first partition contains the class name. This partition is containing the class name. So here class name is customer. The second partition contains all the attribute of the class. So like these are all the properties of existing object. If customer is an object or class, so these are the property that class inherits. So ID, name, account number, date of birth, address, there are many more. Now coming to the third box. So this is the behavior of this class that this customer has. So the third partition contains all the functionality of this particular class. So customer can log in any system. It can, if it is a bank customer, then it can open an account or log out. So this is a one kind of diagram that is called class diagram. It represents the class. Second important component is UML. So as UML is a graphical language, it supports two types of diagram that can be classified as structural and behavioral. So this one is structural and this one is behavioral. So the structural diagram is used to create a static model of the software. That is, it gives an idea about what all components build up the system. So it's give an idea about like what are the components that are required to build up this required system. And the behavioral diagram, it is about the dynamic behavior of the application or the system. It means it is used to create a dynamic model of the software. It tells how the different component or module that we have designed will interact each other. So this is the about the UML. It's simply a graphical representation of the functionality and behavior and static structure of the system. Some of the diagram that is supported by the UML in structure and behavioral UML. You can see here in structural there is a composite structure, deployment UML diagram, class diagram, and object diagram, and component diagram. So for our purpose in this course, these two diagrams are very much important. And component diagram also we will see in a very starting phase when we start developing one application. In the same way, in the behavioral UML diagram, we can see there are multiple type of diagram that is supported by the UML: state machine diagram, communication diagram between the object, use case diagram, and activity diagram. So these two diagrams we are going to discuss in the next coming lectures in the session. And one is the sequence diagram. This will also we will understand like how this communication happens between the objects. There is a sequence and pattern of that. So this is all about the UML. One of the very important aspect of the object communication, that is their relationship. So in design of the system we have to take care of the relationship between the different objects. Like if I take one example that you have seen in the earlier session also, like customer class that we have created as per the class diagrams. But it's very strange, there is one class here and there is another class here, but there is no relationship between the class. These are two standalone entity in the universe. I mean, this is in the real time or in the reality, this is not possible. So in real world, the objects are related to each other in one or the other way, and the same should be also reflected in the class diagram. So there can be a connection between customer and bank account, that customer can own the bank account, right? I mean, customer can be the owner of the bank account, and based on this relationship, they have some certain behavior. Like customer can operate his account, he can withdraw money, he can I mean he can send money, he can do a lot of a number of operations that is based on the relationship, right? Let's take one example of two people in the real world. There is one object that is object 1 and there is another object 2. If these two objects are two persons, so their relationship can be anything. They can be friends, they can be father son, or they can be husband and wife, right? So so their actions, like whatever action between these two objects will be are expected, that will be completely depend on their relationship type. So so we can say that their action will be different depending on the type of the relationship that they share, right? So in case they share a father or son relationship, then son will inherit the surname of the father, which could which could have never been possible in case of friendship, right? So similarly, in the class diagram, two classes can be related to each other in many different ways. Hence we have different type of relationship to represent this kind of relation, a different relation. So in the class diagram, the classes can be related to each other through association, generalization, aggregation, or composition. So let's understand the association. So association is nothing but we know that we can connect two classes with a solid line. See, if I draw one solid line over here, so we can say that this class 1 is related to class 2. But but at a matter of fact, we know that the classes actually do not exist, but the object created from these classes do have the existence. So you must understand one thing over here, that it is actually the object that are connected to each other, but in class diagram we connect classes to show how the object of these classes will be referencing to each other, or how they will be connecting to each other. So in this diagram we can see that the class 1 is associated with class 2. If if I put the class 1 as a customer and class 2 as a bank account, so class 1 customer is associated with the class 2, that is bank account. Now one problem over here. The problem is that what kind of relationship they have. I mean, every relationship has its own name. In the real world we can see that either it's a son father son relation, it can be a friendship, it can be a a spouse relationship. So we have to give some name to this relationship, class 1 and class 2. So if I take one example, suppose this class 1 is a teacher and class 2 is a student. So what kind of relation they will carry? The relationship will be that class 1 as a teacher teaches to class 2 as a student. So teacher teaches a student. So the teachers will be the relationship name. So teachers will be the relationship name. So this name is nothing but it's a verb, and this name defined as a relationship as association between the classes, how these classes are associated. So this class 1 and class 2 are associated by the action, that is teaching, teachers or teaching. So these two objects, teacher and student, can have multiple association. One of the association that we have discussed, a teacher can teach to his students. But there is another association that we can discuss. That is, teacher can give test to a student. So here teacher is behaving as examiner and a student is behaving as an examinee. And the relationship will be changed over here. Now the relationship will be teachers gives test to the students. This is one more association between the classes. So we can see here teacher is playing a different role in different association with the students. So I mean, this can be reflected, we can reflect these roles in the class diagram as well, because their relationship gets changed based on their role. So simply we can put their roles. So here I have put the role mentor, and here I have put the role of mentee. So now we have considered the role of the communicating objects as well, as per their association is derived by this role. Another type of relationship is the generalization. So let's analyze our bank account class that we have created. So it's having some number of properties and some methods, right? So we can see that it has one attribute that is of type. This attribute is type parameter, you can see here. So this means that there can be a different type of accounts. Let's suppose there are two types of account in any bank. The one is the saving account, one is the current account. And if you have some idea about the banking system, you might be aware that the bank impose different rules for the deposit and withdrawal on different types of account, right? So this means when we write the deposit or withdrawal function, we need to check first what kind of what type of account it is. So in this, you can see here we are checking these things, like whether account is type of saving or current, right? If I talk about the implementation, you can see here I have created one bank account class, and every time I am checking whether this account is a saving account or current account. Though it's not a very good programming, because every time I'm checking this account type, then we are doing the processing according to the account type. So let's see another implementation which is a good code, and we will analyze that. Now here I have redefined the implementation. So here I have created two types of class. One is the saving bank account and another is the current bank account. These are having all the methods that is required for that saving accounts or current bank account, and they are inheriting that all these properties from the parent, that is bank account. So it's the code is looks like a very clear code over here. So if I understand this scenario where we have created two new classes, one for the saving account and another for the current account. Now these classes have their own definition of deposit, withdraw, and transfer methods. So hence if a customer withdraw from the current account, then the withdrawal method corresponding to the current bank account object will be called. So I mean the clarity of the code and readability of the code is very clear, so there is no confusion. So this can be considered as one of the good design and good implementation. So as of now we have seen two types of relationship between the classes, that is association and generalization. Now it's time to understand the third type of relationship, that is aggregation. So so whenever we need to represent any object or any class that is a part of some other classes, we can use the aggregation. Like if you take example of a car, so car is an object and this object is having another object, that is wheel, right? So we can say that car is car is a object or class which is required the wheel object, or wheel is a part of a car object. So this is how we used to call this aggregation. So I mean this is a diamond relationship. So if it, if I see this diamond relationship, right? So this diamond relationship is tells about the composition, whether it's a part of or it's as a whole. Now coming to another type of relationship between the objects, that is composition. So in case of aggregation, we have seen in the last example also, we saw that two classes had a part-whole relationship. It means one class was a part of another class. So if I take example of car, and we know that wheel is a part of car, but somehow if this car object get destroyed, still the wheel can exist, right? In the same way, if I take an example of bank account and that their locker, so if bank account is object is lost, but still locker object can still survive, right? In another example we can take as a library. Well, if library is closed or library doesn't exist, but still books can exist, whether books is a part of the library. So we can summarize that in case of aggregation, the part can exist without the whole class also, right? Because your wheel can exist without the car. So let's take another example. Just think like one bank account is there, and the account always has a transaction history associated with it, right? So if we consider the bank account and transaction history as two different objects, so we can say that transaction history is a part of bank account, right? So if somehow bank object is get lost or you get destroyed, then there is no meaning of transaction history, because a transaction history cannot be exist without the bank account, right? This makes sense also, right? So we can say that. So this is, I mean, actual this is the example of composition. So composition is nothing but is the stronger form of aggregation, in which if aggregated is destroyed, the part are destroyed as well. Unlike the you know unlike the previous example where we are just considering the car object is lost, but still there the dependent object was still surviving. So we represent this as a help of filled diamond shown. Here if I show you, so this is the filled. It's a diamond relationship, which the empty diamond used to represent that if the car object is destroyed, still this object can survive. But if it is a filled one, then if car object get destroyed, the wheel object will also get destroyed. So this relationship can be shown by composition, right? Actually, it's the same as no, irrigation. The only difference is that it's not a part or whole dependency; it's complete dependency on that. If the parent that gets destroyed, the whole object and dependent object will also get destroyed, just like bank account and transaction history, right? So these are the some important components or concept which is required to go ahead with the session. So we have understood all these basic requirements, whether all type of relationship, class diagram, object diagram, and so all this now we have completed this. So now in the next session we are going to just take one little example, or going through one class diagram. That is, I'm going to consider bank object, like how the bank are relationship with other component, what are the operations that other component or stakeholder is to perform. So we are going to discuss that in the next session. Until then, bye. Welcome back. In this section we are going to make a bank class diagram. It's time to bring together all the concepts that we have learned so far, and will create a final class diagram of a bank. So our step will start first with the thinking of the all the components which interact or which exist in any banking system. Like bank itself a standalone object, right? Apart from that, there are multiple objects. We can first we'll find out all these component that are required to make a banking class, and then we will try to establish the relationship or communication medium between this all the component. So let's first write the components. So first, bank component, right? Another can be a bank can have a locker. Yes. Now bank can have a customer. Then a customer can have a account, bank account, and this bank account can be a type of multiple types. Like I'll consider here saving account, and then current account. Other component can be a bank employee, and a any account can have their own history of transactions, right? So we can write here transactions history. So these are the components that we can consider it to make a bank class diagram. Okay, so now we are ready with our components. We can write it like that. So these are our components: bank, locker, customers, employee, bank account, type of account, that is saving, current, or PF, or any loan account, and transaction history of the all any accounts, like it's a saving, current, or PF, or loan, right? So now we will try to make a relationship between this all object. As of now, this object are just a standalone object. There is no communication between them. So you have to establish the relationship. Let's do that. So I have taken four component as of now. One is bank, one is locker, and another one is the employee, and one more, that is customers. So now let's establish the relation between them. So first I'll consider this bank object. Now we have to think of like what a bank can have. So a bank can have an employee, a customer, and the locker. And we in the last discussion we have seen that we have to give the name to every relationship. So we know that a bank can have multiple customers, right? And one customer belongs to multiple banks as well, right? So we have to give this relationship has a bank has a customers and a customer has banks. And these two dots with the black dots, that is for the that is a open ended. I mean there is no number or there is no limit on the count, right? So it is kind of n, you can say. So one bank can have n number of customers and one customer can have n number of banks, right? Now the same relationship I am considering here is for the locker. In locker, what is happening? We know that a bank can have locker, but every bank has their own capacity to keep the locker. It may be some number, it may be some foundation, like it may be 5 or 10. So here I have considered the 10. So we can say 1.10. 1.10 means one bank can have 10 lockers. And this relationship is a diamond relationship. It means if somehow this bank is closed or bank is destroyed, the locker object still can survive. So this is the empty diamond relationship, right? So now coming to the employee. So we know that one bank can have n number of employees. So here in the employee, the properties are like ID, name, address, and I've taken some function also that this class can perform or this object can perform is update personal info. We also know that in the last session we have discussed that very clear way, like depend on the role, the relationship name can be changed. Like when we enter in a bank, remember there will be one reception counter, there will be one bank counter where you can deposit the cash, there will be one counter where you give your passbook to get printed. So all these are employee, but their role are different, and based on the roles they are performing the different tasks, right? So I have just taken one example here. I know that can manage one employee can manage customers, but if this customer role is relationship manager, then the action will be like this particular relationship manager manage the client. Now it's not a customer, it's a client. So this is how we have established the relationship between this four object: bank, locker, customer, and employee. So now if I extend the customer to the bank account object and then transaction history. So we know that one customer in one bank can have only one account, and one account in the bank belongs to only one customer. So this relationship you can see here, I have given one, right? And here is also one. So it means that the relationship name is owns. It means customer owns this account. He is the owner of this account. So this is one-to-one relationship. Now the one bank account can have transaction history, right? So this is one. I mean, one bank and account can have only transaction history, and that transaction history can be filtered out. So filtering is not considered over here because it's not a functionality of the it's not a part of designing. It's all about implementation. So I have given this, sorry for bad shape. I have given this diamond relationship with filled some color. It means that the transaction history will not exist if this bank account is closed, right? In the case of locker, even locker was existing though bank was closed. But if bank account is invalid or closed, then there is no point of keeping the transaction history that will be shown to the customer, right? So this is how all this relationship has been maintained. And we also consider one more point, like we know that bank account can be of many type, right? So one can be account of saving type, saving bank, and one can be current account. So these two type of relation will be nothing but it's the inheritance of the or extension of the bank account class. So I'll simply just keep a simple relationship which will inherited by them, and this will be one arrow over here because this classes extends or inherits the parent bank account. So this is how we establish the relationship, and it's a very simple bank class diagram. I have just given this demo just to brush up the concept that we have learned in the last section, like what is the relationship, what is the composition, what is the inheritance, what is the class diagram, what is the object diagram, right? And what is a one to n, or what is the both pointed star, and what is the relationship name. So all this concept I just brush up with this bank class diagram. So now onwards in the next section we are going to take a numerous examples and we will discuss this all the component of each example and establish the relationship. So this is what the aim of this course. We are going to learn how to design any applications. So let's do that. Until then, bye. Welcome back. In this section, we are going to talk about one app, Book My Show. Book My Show is a moving ticket booking app. On this app, we can book any ticket for any given movie or we can book any live show. So in this, what user can do in this application, user can log in the application, he can browse the movie, he can select one movie, he can choose his preferred show timing and he can book the ticket book, or book his seat. So this is what this application is about to perform. So let's discuss about this requirement. As a part of the previous section, we have discussed about the steps, and this step is nothing but there are 5 steps, and these 5 steps should, if you follow these 5 steps, all the requirement gathering can be completed and application also can be completed. So the steps of object oriented analysis and design is that first we have to gather all the requirements. Once this step is complete, after that we have to create the use case diagram. Once this use case diagram is complete, then we have to design our class diagram. And in the class diagram, we have to fill all the properties, all the function that that class has is nothing but is a step 4. Once this all this method will be filled of a given class, then we have to write our logic and complete the code. So this is the step that we are expecting. This is not a very hard and fast step. You can miss some, you can add some more step also, and you can reduce some step also. So adding more steps, it means that sometimes it happens whatever your design that you have thought of, it may be some changes due to some current situation or behavior. Like it may be the situation that you want to restrict some particular user, or you want to give more flexibility to a particular group of users. So all these changes used to happen and design gets changed. But as a part of a study, we are going to perform this 5 steps. So the first step is gather all the requirements. So gathering all the requirement is happens through some documents. Either go through some documents or you discuss the problem with the SMEs. SMEs nothing but nothing but it's a subject matter experts, people who have a broad knowledge about this particular domain. So let's see that. So my first requirement will be there. This app should be, this app should show all the current movies and the show, whatever is running. Next point should be this app should allow all the users to search the movie. They can browse any movie, and this app will be listing the different shows for a given movie. If user has selected one movie, so there may be a 4 or 5 different shows timing. So it shows all the timing. And this app should allow only registered user to book the ticket for a show. So here there will be 2 types of user. One user which is not registered, we are calling them as a guest. So once a guest user is coming to the app, he can only able to browse the movies, but he cannot book the movie. Only registered user should be allowed to book any ticket for a given movie or show, right? Now to change the movie's timing or change the movies, only theater people or theater users should be allowed. So app should give permission to the theater's user to add and edit a show. So this is all core requirements, and apart from this core requirements, there may be some other points that we have to consider. This is nothing but this is called assumptions. So these assumptions used to come by discussion with the client or discussion with the SMEs. So for this particular application, Book My Shows, there may be multiple things like screen should be multi-screen, how many floors are there. So all this will be part of assumptions. So it should be a multi-screen, or what is the criteria to seat selections. what should be the payment method, is the API payment, card payment, or direct bank account payment, or how many languages that we are going to support. All these are points which can be considered, as a part of assumptions. So we also took some assumptions while developing this app. So in the next sessions or next continuous subsequent lecture, we are going to discuss about this multiple criteria. So my first assumption is that every theater has a single screen, right? The second assumption is that every theater has some capacity. And here capacity calculation is nothing but whatever the number of seats that you have given, that is the capacity of a given theater. This point we have already discussed that registered user can book ticket, but guest user are not allowed to search movies. The guest user should only allowed to search movie. They cannot be allowed to book any movies, right? So the green point you are looking at, this is the registered user. It is having some user ID. He can do all the tasks. He can perform the ticket. He can perform the searching. He can book the ticket. Next point is that a registered user will have the history of their booking. Of course, only registered user are allowed to book the ticket, so they are only having their all the previous bookings details. This is nothing but the history of booking. This is very much necessary because because this feature only gives power to user to cancel or edit their bookings. So movies can be in two languages. So in Hindi or English. This is my assumption, but we know that there are multiple languages. It may be Tamil, it may be Telugu, Bengali, like that. So, but for this consideration, we have just taken these assumptions. And movies can be any kind of genre. In this genre, this should be can be action, romance, comedy, horror, drama, and child film, animation. But here we are just considering four genre, that is action, romance, comedy, and horror. So right now payment method we are not including because of it's we are just making sure that the purpose of this this demo or this section or lecture is that we should understand how to design the application. In incorporation of the payment module is a different kind of things, so we have to no you have to register ourselves in some sandbox for a given bank or some credit card, then we have to do that. So right now I am ignoring this part, so it will be considered that once you are clicking on book or book my show or book my ticket, internally this get paid, right? So this is my assumptions I have listed out here in the left side. That is, every theater has a single screen, every theater has some capacity. A registered user can book tickets, but guest users are not allowed to search movies. Are allowed to search movies. Registered user will have the history of their bookings. Movies can be in two language, Hindi and English, and movies can have any of the four genre. The genre I have considered is action, romance, comedy, and horror. So this is my final requirement. This is my core requirement because this core requirement is required to make any system. It's a minimum set of requirement which should be considered to make this application, book my show. And these are the assumptions. The assumptions are the based on that we are sure that we have to make system such a very easy and very feasible way, so that we can solve our purpose to understand the application. And the assumption should be on base, like suppose if I take a first example, that is every theater has a single screen. It means right now it is having the single screen, but application should be like that. It should be extensible to include the multiple screen, right? It should be extended. It's just based on the open close principles. So in the next section, we are going to see the second step, that is how to create the use case diagram. I'll just brief about that. Use case diagram is nothing but in this we have to find out the type of users and their actions. And based on that, we have to establish the relationship and all the concept that we have learned so far. So until then, bye. We'll meet in the next section. Welcome back. In this section, we are going to discuss about the second step, that is creating the use case diagram. Creating use case diagram for any system is depends on the requirement that you have gathered in the first step. So, in a simple way, use case diagram is nothing but it's a relationship between the actors and their actions. Right, so we have to find out some basic parameters that are required to make any diagram, which is no, or you have to find out those parameters which have capability to give power to use case diagram. So let's find out those parameters. So in this case, we have to find out the first step is to identification of the actors. Actors are those objects which interact with our system, right? So you can say in a simple way, it's the users. Second step is identification of the use cases. The use cases means all the actions or all the functions that can be performed on the system. Then we have to make a relationship between the actors and their use cases, which is nothing but association. So there are some action in our system which is not, individually they do not exist, but it is a part of some bigger actions. So that is, we have to identify the inclusive use cases. Then coming to the next point, there's the extension use cases. Like we have taken some assumptions in the starting that it's a single screen or multiple screen. So right now we are considering the single screen, but in future it should be extensible. It may be a multiple screen. So those identification is required. And apart from that, we have to find out those classes which can be, act as a abstract. Right. So these are the parameters. We will see one by one how to identify them. So first step is to identify the actors. So I told you in the requirement we have to find out those object which going to interact with the system. So first let's see what was the requirement. So in this requirement you have to find out those people or those object who are going to perform any action or system. So I have highlighted those names, that is user and theater, right? User is used to book, search, or find out the show, the ticket, and theater is used to change the movies and their show timings, right? So this is the use case diagram. If you take out this use case diagram, so our diagram will be like this. In this, on the left panel, on the left side there is a user, anchor or actor, and the right side there is a theater. So they have their own certain functionality, that is nothing but that use cases. Let's go to the requirement again. So in the requirement you have to find out all the actions that is performed by any actor. So in the second point, we are writing that user to search the movie. So searching the movie is action. In the same way, ticket booking is an action, and for the case of theater, add and edit of a show is an action. So these three are action. Apart from that, user can also register on the application. So registration and login. This can be considered as a action. So we have to draw this on our next picture. That is register, login, search, book ticket, add, and update show. So as of now, we have identified the actor, we have identified their use cases. Now we have to establish the relationship between them. Like what action can be performed by which actor. Now let's associate the actors with their use cases or functions. So here I have identified the functions that can be performed by other users. So if it is user, so here I'm not distinguish about between the users which are registered or non-registered. So right now any user have to perform the registration action, then login action, then he can search movie and he can book ticket. In the same way, the theater owners or theater users can add the show or update the show. Now we have to find out the inclusive use cases. I told you, inclusive use cases are nothing but it's a hidden actions that can be performed inside a bigger action. If I take one example over here, that is, I'm doing here booking ticket, and booking ticket is have two actions inside that. One is the select. You have to select the show, and then you have to make a payment. So here, select show and make payment are inclusive actions. So if any user is booking ticket, it means that he has must selected the show and he has made the payment. Then only ticket can be booked. So I have given this association with this line. It's dotted arrow, and you have to in a greater than less than signs. We have to put the include actions. So it means that book ticket has inclusive action, that is select show. Right now, here we can see that I have taken a user as a bigger object, and we know that user can be two types. One is a registered user and one is the guest user. So I have to make some abstraction over here. This is called finding out the inheritance. So I have added the inheritance and I have created one base class, that is user, and I have extended two more class, that is guest user and register user. Now, so according to their role, the all the association will be remodified. So we have to rechange it. So now the association will be like that. Guest user can register and guest user can search the movies, right? And so right now, since the common action will be performed by the user, so searching the movie is a common for guest user and registered user both. So I have searching movie, I have associated with the base class, that is user. Now registered user can log in the application, he can book the ticket, but guest user cannot book the ticket. So I have not given any association with the book ticket. In the same way, for the theater can add or update the show. So this actions is not going to be changed because a theater is one entity there. He is the owner of, no, there is no two types of theater owners. So now coming to the next point. So till now we have created our class diagram and we have seen that this is a complete class diagram, right? So all the actions that you have written here, like registration, login, user, guest user, register, these are nothing but the class. Now when we make our class, so it will be a skeleton of that class, and in the later stages we have to fill all this this classes with their properties and functions. So we'll see that in next session. Welcome back. In this section, we are going to make a bank class diagram. It's time to bring together all the concepts that we have learned so far and we'll create a final class diagram of a bank. So our step will start first with the thinking of all the components which interact or which exist in any banking system. Like bank itself a standalone object, right? Apart from that, there are multiple objects. We can first we'll find out all these components that are required to make a banking class, and then we will try to establish the relationship or communication medium between this all the component. So let's first write the components. So first, bank component, right? Another can be a bank can have a locker. Yes. Now bank can have a customer. Then a customer can have a account, bank account, and this bank account can be a type of multiple types, like I'll consider here saving account and then current account. Other component can be a bank employee, and any account can have their own history of transactions, right? So we can write here transactions history. So these are the components that we can consider it to make a bank class diagram. Okay, so now we are ready with our components. We can write it like that. So these are our components: bank, locker, customers, employee, bank account, type of account, that is saving, current, or PF or any loan account, and transaction history of the all any accounts, like it's a saving, current, or PF or loan, right? So now we will try to make a a relationship between this all object. As of now, this object are just a standalone object. There is no communication between them. So you have to establish the relationship. Let's do that. So I have taken four component as of now. One is bank, one is locker, and another one is the employee, and one more, that is customers. So now let's establish the relation between them. So first I'll consider this bank object. Now we have to think of like what a bank can have. So a bank can have an employee, a customer, and the locker. And we in the last discussion we have seen that we have to give the name to every relationship. So we know that a bank can have multiple customers, right? And one customer belongs to multiple banks as well, right? So we have to give this relationship has a bank has a customers and a customer has banks. And these two dots, the black dots, that is for the that is a open ended. I mean there is no number or there is no limit on the count, right? So it is kind of n, you can say. So one bank can have n number of customers and one customer can have n number of banks, right? Now the same relationship I am considering here is for the locker. In locker, what is happening? We know that a bank can have locker, but every bank has their own capacity to keep the locker. It may be some number, it may be some foundation, like it may be 5 or 10. So here I have considered the 10. So we can say 1.10. 1.10 means one bank can have 10 lockers. And this relationship is a diamond relationship. It means if somehow this bank is closed or bank is destroyed, the locker object still can survive. So this is the empty diamond relationship, right? So now coming to the employee. So we know that one bank can have n number of employees. So here in the employee, the properties are like ID, name, address, and I've taken some function also that this class can perform or this object can perform is update personal info. We also know that in the last session we have discussed that very clear way, like depend on the role, the relationship name can be changed. Like when we enter in a bank, remember there will be on reception counter, there will be one bank counter where you can deposit the cash, there will be one counter where you give your passbook to get printed. So all these are employee, but their role are different, and based on the roles they are performing the different tasks, right? So I have just taken one example here. I know that can manage one employee can manage customers, but if this customer role is relationship manager, then the action will be like this particular relationship manager manage the client. Now it's not a customer, it's a client. So this is how we have established the relationship between this four object: bank, locker, customer, and employee. So now if I extend the customer to the bank account object and then transaction history. So we know that one customer in one bank can have only one account, and one account in the bank belongs to only one customer. So this relationship you can see here, I have given one, right? And here is also one. So it means that the relationship name is owns. It means customer owns this account. He is the owner of this account. So this is one-to-one relationship. Now the one bank account can have transaction history, right? So this is one bank and account can have only transaction history, and that transaction history can be filtered out. So filtering is not considered over here because it's not a functionality of the it's not a part of designing. It's all about implementation. So I have given this, sorry for bad shape. I have given this diamond relationship with filled some color. It means that the transaction history will not exist if this bank account is closed, right? In the case of locker, even locker was existing though bank was closed. But if bank account is invalid or close, then there is no point of keeping the transaction history that will be shown to the customer, right? So this is how all this relationship has been maintained. And we also consider one more point, like we know that bank account can be of many type, right? So one can be account of saving type, saving bank, and one can be current account. So these two type of relation will be nothing but it's inheritance of the or extension of the bank account class. So I'll simply just keep a simple relationship which will inherited by them, and this will be one arrow over here because this classes extends or inherits the parent bank account. So this is how we establish the relationship, and it's a very simple bank class diagram. I have just given this demo just to brush up the concept that we have learned in the last section, like what is the relationship, what is the composition, what is the inheritance, what is the class diagram, what is the object diagram, right? And what is a one to n, or what is the both pointed star, and what is the relationship name. So all this concept I just brush up with this bank class diagram. So now onwards in the next section we are going to take a numerous examples, and we will discuss this all the component of each example and establish the relationship. So this is what the aim of this course. We are going to learn how to design any applications. So let's do that. Until then, bye. Welcome back. In this section, we are going to create the skeleton of the code, the class diagram that we have completed in the previous section. Now we have to fill that class with all the properties and methods. So simply we are going to create the whole classes. And all these classes will have attributes, and in the later stage we will create the getter setters and their other methods which are required to access the other objects. So let's do that. So now we'll start with the enumeration. The enumeration class that we have created in the design, we are going to discuss that. If you see here, if you remember the last design that we have done in the last step, in the previous slides and previous sessions, that was you have created two genres. One genre is for the what kind of type of movie is it? Is it action movie or romance or comedy or horror? And another genre, another enemy was the language. So which language this movie belongs? It's a Hindi or English. So it was our assumptions that this will be only the types of language and the types of genre will be there. So I've created the enum for that, and now this relationship or this will be composed with the movie class. Okay, so right now I'm not going to touch the movie class. First I'll create the user class. So I'll move to this create the user. First I'll create the user class, then I will extend this class to the guest user and register user. I have created the user abstract class, and this user abstract class will have only those parameters that are common to all kinds of user. That will be his ID and name, and I have given some constructor as well to create the object and simply getter and setter of this property. This is a static parameter because this has to be beyond the object, so I have taken this parameter as a static parameter. Now coming to the other two types of users, which will extend this abstract class user and add some more functionality in that. Now if you see at the registered user properties, so registered user will be extending the user abstract class, and it will have the some function like it will be related to the ticket. I mean, registered user can book the ticket, so all the book ticket will be history. So there will be some array list or kind of list which will contain all this book ticket by this particular registered user. And registered user can book any show, and this show this show will be nothing but he can cancel. He can, if he is having the history, so he can cancel the ticket as well. So all the relationship we have shown here. So this is the nothing but the list of history that all the tickets that booked by this particular registered user. And this is the way to create the register user. Whenever register user, when the object of register user will be created, so we have to pass the name and all the tickets that is created by this particular user. Now this function is for to cancel the ticket from this list. Okay, now to guest user will also be created in the same pattern. It will extend the user and it will have the only method that he can register itself, right? So this registration method is whenever guest user will browsing the movies. So at the time of booking, he has to be a registered user, right? Now I will create the movie class, and movie class will be consist of these two genres and a language enum that you have defined in very beginning. So and every movies it has name and it has rating, right? So these all parameters will be used to create a movie object, and apart from that we'll be having some getter and setter of these properties. We'll see that in later. Now coming to the class show. So class show will be having some timing. It will have the movie object. It will having the screen. Here screen is nothing but it's a theater. Okay, so and it will show like when we are going to book a show, it will be showing like how many available seats are there. So these three parameters are there. So all these classes you already have created. Theater is nothing but it's a screen. In assumptions we have taken this consideration, like since there is only one screen, so theater will be behaving as a single screen. And every show will have some its own id or some reference id or application or booked id. So that it will be shown here, and rest parameter is nothing but it's all coming from there. And the show object, we will, like one theater can have multiple show, right? So when show object will be shown to any user, it will be having the list of object. Like I mean, whenever you are going to book a show, so that object will be, the show object will be added to the all the shows available for this theater class, right? Whenever any object of show is created. Fine. Now I'll create the object of ticket. So ticket class will have the two objects that will be the booked show, because ticket will be consisting of nothing but is the show details, like what is the show time, what is the show name, and what is the screen or what is the theater name, and who is the owner of, I mean, who is the visitor of this ticket, who will carry this ticket, and I mean and number of seat. It means that what if the seat is allocated to him, right? So this is that belong. I mean, better will be like if you write seat number, that will be better. So this is what we have done in this. So it's a very simple class. Now moving to next class. So this is one of the important concept here, that booking a ticket is always, this is the page or this is the particular part of the design where multiple user will be attempting to book the ticket for for one seat. So there can be a race condition, or there can be some blocking thread that will block the other users. So you have to create some threads which will do this job, and the booking book ticket method should be synchronized. If one is ticket for that particular seat idea, some particular seat number, no other threads or no other user should be allowed to book the same, unless and until it is coming out of that particular section, right? So this section is otherwise is a critical section actually in a very technical term. So uh, so in the same way we have to create this thread, and this thread will extend a thread, and it will having the object who is going to book that ticket, that is registered user, and which show it is going to be book a ticket, right? So this is all about this booking thread class. And here I have given one method that is nothing but the ticket object will be coming from this show dot book ticket. A book ticket will be method which is having user and number of seats. Or once I mean this method will be executed, I mean, this book ticket is a synchronized measure, remember. So at any point of time, only one thread or only one user will be booking that particular seat number. There will be no possibility that two threads or two users are booking the same seat, right? So we have ensured this by using the synchronized keyword over here. So now coming to the next class. So now this is the method that I was talking about, book ticket. So in this book ticket, what you are doing is a synchronized method first. Like so, this is very important keyword over here to keep to ensure that there should be no starving, or there should be not a case when multiple threads are waiting for the same seat and they're block each other. Blocking thread will be not available here, and this is nothing but I am creating this the seat once the seat when we are going to book the ticket. So at that time we have to no minus this minus one from the available seats, so that it can be no, manage the total number of available seat as well. And once this ticket will be booked, I mean everything is successful, payment is made, so we have to add this ticket to the user booking history, remember, right? So now this is how booking history will be created, and at any point of time user wants to cancel that ticket, nothing but in the cancel you have to just release that seat and you have to increase the available seat count, right? It's very simple. And I mean of course once the seat is cancelled the payment will be returned, so that's a different mechanism, right? So we are not considering this payment design over here. Now coming to the theater class. Theater is nothing but a screen, so it will having all the relation, all the parameters, all the properties of the screen, like name, location. Location here is maybe on a floor or something like that, and how many people can sit. That's the capacity, and this capacity is nothing but is the total available seats, right? So and how many shows that particular shows is running in that particular screen or theater. This number of shows may be a different movie show, right? So this is what we have defined as a low level design of these classes. So as of now, we all have seen like what are the property that we can incorporate it, and how this relationship can be established based on the composition of the different object in one class, right? So now in the next section, what we're going to do, we'll write some logic for this code, and we'll try to create one main method, and we'll try to create all the object and setting this all the object in the corresponding bigger classes or parent classes, right? So this is how I mean this is what a low level design. One thing I want to iterate over here, like there may this is one of the start, like how to design any given system, but believe me, there may be a numerous number of approach and which will be better than this. So it's just a start of thinking. When you do this thing two times, three times, there are multiple things will come that you'll find the best way to represent that particular object of that particular composition or relationship, right? So just as a beginning. So I mean, this is one of the basic way to thinking of like how to design. It's all about our thought process, like how we are improving and how we are thinking. So, so until then, let's wait for the next session. Until then, bye.